May 2024, Paper 2, Time Zone 1, Question 8. So for question 8a, we would graph the function h. And so then we would go to second trace, minimum, enter. So we will get that t is 5.138010219. And then we would do that for maximum. And we will get that t is 11.26198. And then for the time between, that would be 11.261981. And that is around 6 hours and 7 minutes. So therefore, m equals 7. Then moving on to part B, we would want to determine the length of time when the height of the water is less than 1 meter. Go to y equals and add y equals 1. Then we could look at the intersection. So for that, we will go to calculate again and then choose intersect. And we get that x equals 3.56919975. And then we will repeat that for the second intersection. And we get this x value. Therefore, that would be 3.14 hours. Then for part C, we would add the derivative of the function. And then we would add calculate, where we put in value, and we know that it is at when t or x equals 13, and we get that it is equal to negative 0.650623. Therefore, we add Therefore, the answer would be negative 0.651 meters per hour. And this is because it is the rate of change where we would take the derivative. Part D. So for part D, A, or the amplitude, is equal to 2.74 minus 0.4 over 2, and that is 1.17. Then D equals 2.74 plus 0.4 over 2, and that is 1.57. Then we could substitute these values into the function where 1.17 sine B bracket 241 over 60 minus C plus 1.57 equals 0.4, and thus B times 241 over 60 minus C equals negative pi over 2, and B times 2 over 60 minus C equals pi over 2. And then we could solve these simultaneously, where 241 over 60 minus C over 2 over 60 minus C equals negative 1. And thus, C is around 5.86. Then subbing it back into a point, we could get that B is around 0.495. Then for part E, we graph both of the functions. So h of t and h of t. Intersect, and we will get that t is around 4.16.